Hello everyone, welcome back. So I'm Kavi, I'm a system engineer. So in this video, I'm going to be talking about VARP and Anycast gateway. So VARP and Anycast gateway are first of redundancy protocol used in Arista switches. So these are open standard protocol, but today I'm going to be configuring VARP and Anycast gateway on Arista switches. So let's see what is VARP and Anycast gateway. So VARP and Anycast gateway are two different protocols. They're not the same. So what VARP or Anycast gateway does? So basically, they allow two switches to share the same IP and the MAC addresses. These IP address and MAC address are virtual IP and virtual MAC addresses. So usually, the two switches are in MLAG, but they don't have to be in MLAG to be, to configure VARP and Anycast gateway. So basically what happens, two switches, they will share the same IP and same MAC address. And the devices which are connected to the switches, the endpoints or the host, they will have a single IP, I mean gateway IP, single gateway IP and single gateway MAC address. And the both switches will be forwarding the traffic simultaneously. It's not active standby, like VRRP. So VRRP provides active standby, but VARP and Anycast gateway provides active forwarding. So we are not. So both switches will be responding to ARP, and both switches will be actively forwarding the traffic. And this is the lab, so that I'm going to be walking. So in the lab, we have a host which is connected to a leaf switch, and the leaf is connected to two spine switches. The spine switches are in MLAG. The leaf connects to both spines via port channel, and we have a WAN switch which is connected to both spines via port channel. And the spines are in MLAG, and we'll be configuring VARP as well as Anycast gateway. We'll be configuring both. So we'll be seeing the difference between VARP and Anycast gateway. So VARP IP is going to be 10.254 and Anycast gateway IP is going to be 20.254. And the virtual MAC is that 001122334455. Okay, so let's get to the lab. So first, let me show you the things. This is the host. I have already configured the host, leaf, and the WAN switches. So there is no. So I have already done the configuration on the host, leaf, as well as the WAN switch. Let me show you. So LLDB neighbors. So you can see here the first. Let me show you the lab. This is the container lab. So let me show you this. Let me show you the container lab code. This is the Python script for the container lab. So I have, look at the nodes. I have leaf, spine 1, spine 2, host, and WAN. And I'm using CEOS version 4.33.4M. Okay, now let's get back to the topology. So host is connected to leaf and show interface status. So this is a trunk port. As you can see here, this is a trunk port. So Ethernet 1 is a trunk port and it is connected to leaf 1. And let me go to the leaf now. So leaf is connected to host 1 and the spine 1 and spine 2. And Ethernet 1 is a trunk port which is connected to the host, and Ethernet 2 and 3 are part of port channel. It's port channel 12 which is connected to the spine. And we have port channel 12 which is not connected because on the spine side we have not configured anything. So let me also show you this. Show IP interface brief. It shows we have two VLANs, I mean two SVIs, VLAN 10 and VLAN 20. So VLAN 10 is 10.1 and VLAN 20 is 20.1. And let's look at the WAN side configuration. So WAN switch is connected to spine 1 and spine 2. And Ethernet 1 is part of the port channel and Ethernet 2 is part of a port channel. Port channel 12 is connected to the spine and it is not connected because spine side configuration is not done yet. And show IP interface brief. Now on the WAN switch we have VLAN 99. Okay, we have a VLAN 99 which is down right now, and we have loopback 1 that is 8.8.8. We have VLAN 100, so 100 is not needed. Let me remove VLAN 100. Sorry, no interface VLAN 100. So VLAN 99 which is down right now because there's no interface active for this VLAN, and loopback 8.8.8. And let's go to now. So we are going to be only configuring the spines today. So on spines first, I'm going to be configuring MLAG. First, let me show you this LLDB neighbors. So it is connected to leaf, spine or spine 2, leaf and spine 2 and a WAN switch. And here it is connected. Spine 2 is connected to leaf, spine 1 and WAN. So if you look at the interfaces, no configuration. And let me also show you the MLAG status as well. So MLAG is disabled right now. So let's start the MLAG configuration. So let me explain what I'm going to do now. So what I'm going to do now is that I'm going to configure MLAG between spine 1 and spine 2, and then a port channel towards WAN switch. So this port channel is MLAG port channel. It's called MLAG port or MLAG interface. And towards the leaf as well, I'm going to be configuring a port channel with an MLAG ID. So the port channel with an MLAG ID will become a MLAG port or MLAG interface. Okay. And then after that, once the MLAG is configured, then I will configure VARP on spine 1 and spine 2 as well as Anycast gateway for VARP for VLAN 10 and Anycast gateway for VLAN 20. So let me go to this. Let's first configure MLAG. So first, I'm gonna create a VLAN. So this VLAN is dedicated for MLAG. This VLAN will only be used for MLAG purpose. Next, I have created the VLAN. Next, I'm gonna create a trunk group for this VLAN. So I'm gonna create a trunk group called MLAG peer for this VLAN. Then I'm gonna create a port channel. So this port channel, I'm gonna create a port channel for MLAG. This is gonna be an MLAG peer link. This port channel 100 is for MLAG peer link. So it's going to be switch port or trunk. It's going to be a trunk port because we want the MLAG interface to carry traffic for all the VLANs, particularly 4094. But in case of multiple link failure, we want this link to carry traffic for other VLANs as well. Okay, now switch port, mode, sorry, switch port, trunk group. Now we created the trunk group earlier. Now I'm going to assign this trunk group to this particular port channel. So why we are doing this is because we want VLAN 4094 to be carried on port channel 100 only. Only on port channel 100, VLAN 4094 will be allowed. Rest of the other trunk ports will not carry traffic for 4094. Only port channel 100 is allowed. Now what I'm going to do is I'm going to assign this port channel to the physical interfaces. So interface Ethernet. So 2 and 3 are connected to the other spine. 2 and 3. I'm going to say channel group. I'm going to say it's 100 and mode. Let's say active. Okay. Now it is done. Next, what I'm going to do is interface VLAN. I'm going to create an SVI for the VLAN 1094. And then I'm going to assign an IP address. I'm going to say 172.16. I'm going to say 100.1/30. I'm going to use subnet /30. And next, what I'm going to do is I'm going to say no auto state. I don't want this interface to go down at any circumstances. Then what I'm going to do is show IP interface brief. So VLAN 4094 is configured and it is up right now. And show interface status will show the port channel. The port channel is configured, as you can see, Ethernet 2 and 3 are part of port channel 100, and port channel 100 is configured as a trunk port, but it is not connected because on the other side, spine 2 is not configured. So the simple way to do configure the spine is very simple. Show history, okay? Then I am going to just copy whatever I have done so far. I'm not going to copy the SVI part because SPI differs from SPI IP is different on both switches. So right now, now interface VLAN 4094 IP address. Okay, IP address 192. Sorry, it's 172. 172.16.100.2/30. I'm going to say no auto state. Show IP interface brief. Now it shows that 4094 is up, and show interface status will show that yeah, port channel 100 is connected. Okay, as you can see, let me show it here as well. Show interface status now shows that port channel is connected because now both sides are configured. Now port channel 100 is connected. Now let me try to ping the peer. Ping 172.100, sorry, 16.100.2. We should not be able to ping, but we are pinging. Show spanning tree. Show run. I think okay, just a minute. Show run spanning tree. So spanning tree is not blocking this interface. Show spanning tree. So Ethernet port channel designated. Show spanning tree. Okay, this is the root. This is the root. Okay, one of the spine is the root. That's why it's not blocking. So let's say, let me explain what is happening right now. So right now, one of the spines is the root. Let's now spine one is the root. So this link, so now it becomes the root link. So it's not blocking. The port channel is not blocking because it's now it is a root port. Okay, so now we are able to ping from spine 1 to spine 2 because one of the spines is the root. But let's say the van is the root. If the van is the root or the leaf is the root, what happens? Spine will block one of the interfaces. For example, this interface will be blocked if the van or the leaf is the root. Since the spine 1 is the root, this link is not blocked. Okay, but there is one configuration that we have to do because we are not going to change anything on the spanning tree. We are not going to touch the spanning tree. But let's say in this case, now spine 1 is the root. Let's say leaf or van is the root. We don't want spanning tree to block the peer link port channel 100. We don't want spanning tree to block port channel 100. So what I'm going to do is no spanning tree, uh, then VLAN ID 100. This command is mandatory. We have to disable spanning tree. Sorry, it's not VLAN 100. It's 4094. So we have to disable spanning tree on this MLAG VLAN. So 4094, we have to disable spanning tree on the MLAG VLAN. Spanning tree VLAN ID 4094. So we don't want STP to block this VLAN. If this VLAN is blocked, the MLAG will split. So we don't want that. So what's next? Next, I'm able to ping the peers. So now let's get into the MLAG configuration. MLAG, I'm going to say peer, so no, local link, local interface. So local interface is VLAN 4094 and peer link is port channel 100 and peer address is 172. 16.100.1. That's the peer address. Then MLAG, sorry, domain ID. I'm going to use my name as the domain ID. So I'm going to do the same on the other spine as well. So just get into MLAG. Then local interface is going to be VLAN 4094. Then peer link is going to be port channel 100, which we have created. And peer address is going to be 172.16.100.2. And the domain ID must be same. Okay, now show active. Show active. So now both sides, domain ID same, local interface VLAN same, peer address different, then peer link port channel same. Now let's see, show MLAG. Okay, you can see consistent. Now show MLAG consistent. So you can see MLAG is consistent. So it is, look at the state, it's active, and the peer config is consistent. Consistent means both configuration on both switches are consistent. So there is no discrepancy or any difference in configuration. And the status is active, and the negotiation status is connected, peer link status is up, local interface status is also up, and look at the system ID. So the system ID is actually same system ID. Both switches are now using the same system ID. So what happens? Both switches, they participated in the election, and the switch, the winner, what happens? The loser has to use the system ID of the winner. So right now both switches are using the same system ID. So basically there will be a primary and secondary. I'll show you. Show MLAG detail. If you look at the detail of this, if you look at the state, it's a secondary, and the peer is the primary. So right now the system ID, the secondary is actually using the system ID of the primary switch. The primary switch show version, you will be able to see it. And look at the system MAC address 199F, and look at the system ID. Let's go here. Look at the system ID 199F. So right now both switches are using the system ID of the primary. Okay. And MLAG active. MLAG ports are 0 right now. We have not configured MLAG ports yet. So since we are configuring MLAG on the spines, the best practice is to connect all the leaf switches and WAN switches to both spines. In this case, all the interfaces on the spine will be MLAG port. So we're not going to configure just interfaces. We'll be configuring MLAG ports on all the interfaces. So because all the spines, sorry, all the leaves and the WAN switches must connect to both spines for redundancy, because both spines are going to be gateway. So we are not using active standby, we are using active active. So both spines will be acting as the gateway. So we have to connect all the leaves to both spines, as well as the WAN switches or border switches, whatever it is. We have to connect them to both spines. So now WAN is connected. Okay, interface Ethernet 1 is connected to, I'll just show LLDB neighbor. See, okay, Ethernet 1 is connected to leaf 1 and 4 is connected to WAN. So I have to configure two MLAG ports. So MLAG ports are nothing but port channel with an MLAG ID, interface port channel. So towards WAN, I'm going to say, I'm going to just use the same port channel 4, switch port, mode, trunk. Okay, then MLAG ID, I'm going to say 4. Then interface port channel 1. So port channel 1 is for leaf. So interface port channel 1, switch port, mode, I'm going to configure them as trunk port. And MLAG ID, I'm going to say, that's it. We have configured two MLAG ports. So MLAG ports are just port channel with an MLAG ID. And we have to configure the same on both switches. It has to be identical. So now what I'm going to do is I'm going to assign the port channel to the Ethernet interface. Ethernet 4 channel group 4 mode active. Then interface Ethernet 1, I'm going to say channel group 1 mode active. Since the interface, the interfaces, I'm using the same interfaces on both spines, I can just copy paste. So history, I can just copy I can just copy this to interface from here to here. I can just copy this and paste it here, and I can just look at the show interface status. Now, port channel 1 is connected, port channel 4 is connected, port channel 100 is connected. All are connected. Show interface status. All are connected because I'm using the same interfaces on both switches. So it's just a copy paste configuration. So it is better to use, let's say you have leaf 1. The easiest way is to connect leaf 1 to Ethernet 1 on spine and Ethernet 1 on spine 2. Spine 1 on spine 2, Ethernet 1, 1, and I'm connecting the leaf 1. Then leaf 1 to Ethernet 2, Ethernet 2. That way, it's very easy. We can just copy paste the configurations because the interface IDs are same. Okay. Next, so MLAG is done. Let me show you now. Show MLAG. Now you can see active. MLAG ports active. We are seeing two MLAG ports are active, and it's still consistent active on this switch as well. I'm going to show MLAG. Okay, I have already published a video on MLAG. It's a long video. I have I have explored MLAG in deep in that video. I will give the link in the description. You can watch it if you want. If you want to understand MLAG in detail. So active ports, we have two active ports. One towards the WAN switch, one towards the leaf switch. Now we are gonna get into the VARP configuration. Okay, the VARP configuration. So first, I'm gonna create a VLAN 10, VLAN 20, and VLAN 99. So VLAN 10 and 20 for host, VLAN 99 for the WAN switch. Then interface VLAN 10. So interface VLAN 10, this is a VARP. So I'm gonna create a VARP here, VARP IP. IP address, say 192.168.10.251/24. Next, this is the VARP virtual IP. IP virtual router address. So I'm going to say 192.168.10.254. This is our virtual IP. This will be the IP for the default gateway. So all the hosts will be using this IP as the default gateway. So next, what I'm going to do is IP virtual MAC address. So I'm going to configure the MAC address now. This is going to be 0011.2233.4455. So I'm going to do the same on the other switch as well. So I can't just copy paste this because the IP addresses are different. So VLAN 10, 20, 99. Sorry, there's a typo. VLAN 10, 20, 99. So now interface VLAN 10. Let's say IP address 192.168.10.252/24. Okay. Now IP virtual router address 192.168.10.254. So IP address, same IP. So next, the virtual MAC address. So I can just copy this. I can just copy this config and paste it here. So now show IP interface brief. Yes, 10.252 is here. Show IP interface brief. Yes, 10.251 is here. So next I'm going to configure the Anycast gateway. So then after configuring Anycast gateway, we'll be looking at the difference between VARP and Anycast gateway. You will be able to understand from the configuration itself. So now interface VLAN 20. This here I'm going to configure Anycast gateway. IP. So here the command is different. IP virtual router. Sorry. IP address virtual. So before for VARP it's IP virtual router address. Here IP address virtual. So now 192.168.20.254/24. That's it. Anycast gateway is configured. Next, on the other side as well. This one I can copy paste because it's the same config. There's no difference in the IP address. So interface VLAN 20 IP address virtual 92.168 dot 20.254. Something is okay. Subnet mask was missing. Oh, sorry. 254. Okay. So now I'm going to do the same for the VLAN 99 as well. VLAN 99. I'm going to configure the 99.1 slash, I'm going to say 30. And here also I'm going to do the same. Interface VLAN 99. Say IP. I can just copy paste. Nothing to worry. Copy paste. There is a small error here. To check. Now I'm going to say show IP interface brief. Sorry. Show IP interface brief. On the other side as well. Show IP interface brief. Now look at the interfaces. Look at the VLAN 10. VLAN 10 is 10.251. But VLAN 20, sorry. There was an error here. It's VLAN 10, 20, not VLAN 30. So I'm going to say no interface VLAN 30. So I'm going to say VLAN 20. Just configure the same IP. There's the IP address. I can just copy paste. Here is the IP for VLAN 20. There was an error here. Sorry. Interface VLAN 20. IP address. I'll show IP interfaces. Brief. Okay, now it's VLAN 20, VLAN 10, VLAN 20, VLAN 10, VLAN 99. Okay. So look at VLAN 10. VLAN 10 is VARP. Look at the IP address on both switches. It's 251 and 252. And look at the IP address of Anycast gateway. VLAN 20 and VLAN 19. Sorry, 99. 254. Here also 254. 99.1 and here also 99.1. So this is a basic understanding. So VARP, we have to configure a local IP, unique local IP. So this is the unique local IP. 10.251 is the unique local IP for spine 1 and 10.252 is the unique local IP for spine 2. So if you want to see the virtual IP, show IP virtual router will show you 10.254. It is the virtual IP. Okay, now no show, and also show you show IP virtual router. So show IP virtual router. Yep, now we are seeing 10.254 on both switches for VLAN 1 and the status is active. The status is active. And you can also see the virtual MAC address here. So the virtual MAC address is that both switches have the same virtual MAC address and so same virtual IP. Okay. Now what we are going to do is, okay, now let's go to the host. First, before doing it, let me see. Show IP route. IP routing is enabled. I'm going to just disable IP routing. I just disabled IP routing. I just disabled IP routing. So IP routing is disabled on both switches. So IP routing is disabled on both switches. So now what I'm going to do is I'm going to go to the host. So I have configured the VARP gateway as well as Anycast gateway for VLAN 10 and 20. So now I'm on the host. So I'm on the host now. What I'm going to do is I'm going to just ping 192.168.10.254. Okay, the ping is not going through. I'm going to just ping 20.254. The ping is going through. So I'm able to ping 20.254, but I'm not able to ping 10.254. So now what I'm going to do is I'm just going to go back to the spines. So now I'm going to say IP routing. I'm going to enable IP routing now. IP routing, IP routing. Okay, now IP routing is enabled on both switches. So now I'm going to go back to the host. Now I'm going to try to ping 10.254. Now I'm able to ping. Now we can ping 10.254 after enabling IP routing. So for VARP to work, we have to enable IP routing on the spines, or wherever we have configured the VARP, we need to enable IP routing. But for Anycast gateway, we don't have to enable IP routing. It is like they are directly connected. But for VARP, we need to enable IP routing because the virtual IP, so the SVI, so what happens on the spine, we have, let me show you, show IP interface brief. So we have a local IP. This is 10.251. So when IP routing is not enabled, actually the packets from the host will not be able to reach the virtual IP because IP routing is not enabled. When IP routing is enabled, the packet is actually what happens. It is routed from the local interface to the virtual interface. So that virtual IP is the virtual. So the packet will actually reach the local IP. Then the packet is routed from the local IP to the virtual IP. So that's how it happens. So without IP routing, the local IP will not route the packet to the virtual IP. So without enabling IP routing, we'll not be able to reach the VARP IP, but we'll be able to reach the Anycast gateway because Anycast gateway uses the same IP. It doesn't use a local IP and a virtual IP. But but VARP, it uses both local IP and virtual IP. So it is routing the traffic between local IP and virtual IP. So for that, IP routing needs to be enabled. So now let's look at this. Let's look at the ARP table of the host. Okay, so ARP, I'm showing the ARP now. So you can see 251 and 252. I can see 251 and 252. This is the hardware MAC address. And look at the 10.254. It's the virtual MAC. 10.254 and 20.254. They are using the same virtual MAC address. So regardless whether it is VARP or Anycast gateway, both are using the same virtual MAC address. So both VARP and Anycast gateway is using the same virtual MAC address, but with VARP, what happens? It uses both local IP as well as virtual IP. We are seeing for VLAN 10, we are seeing three entries: 10.251, 252, and 254. But for VLAN 20, we are only seeing one entry, which is 20.254. Okay. And one more important thing is that VARP is mostly used in the campus network. In the campus network, where we configure the gateway on the spines. So VARP is mostly used on the campus, on the core for active gateway. And Anycast gateway is mostly used on the VXLAN, multi-homing, where we'll connect a host to, you know, 2, 3, 4 sleeve switches. So in that case, Anycast gateway is used a lot because for Anycast gateway is very scalable because we don't need a local IP. But for VARP, we need every switch needs a local IP. Let's say if I am connecting a host to 4 leaf switches, then I need 4 local IPs plus one virtual IP. So totally, I'll need 5 IPs, 5 IP addresses from a VLAN, from a subnet. So and also it's hard to manage. It's configuration also. It's not copy pasting. You have to do. You have to configure everything separately. But for Anycast gateway, it is just a copy paste configuration. You can just copy everything and paste it on the other switch. So it's actually very scalable, and for automation as well. Anycast gateway is very easy to automate. So Anycast gateway is very much preferred in VXLAN setup for multi-homing. And VARP is also used in VXLAN, especially this MLAG dual homing. In those scenarios, VARP is used. But more than 90% of the cases, Anycast gateway is preferred. But for campus, where we have two spines or two core switches acting as a gateway, VARP is a better solution there because since both switches have a local IP, we will be able to test the connectivity. We'll be able to test whether we are able to reach spine 1 or spine 2. We'll be able to test that. But Anycast gateway, it is the same IP, so we'll not know whether we'll not be able to ping both spines separately, because if I'm able to, I'll be pinging the same IP. So we can't test the connectivity towards individual spines. So that's one thing to notice. So let me show the MAC address table of the host. So look at the MAC address table. So it has only one entry, that is for the virtual IP. Now let me go to the spines. Let me go to the spines. Show IP, sorry, show ARP. I'm going to say show ARP, and I'm going to show ARP here as well. And if you look at the ARP table, we have it for 10.1, 20.1, 99.2, and 100.1. Okay, here we have 20.1 and 100.2. So 10 dot. So which means this guy was replying. So this guy was replying to it. So this guy has learned 10.1. Okay, now let me show MAC address table. Let's see the MAC address table. Okay, let me see the MAC address table. Nothing from port channel 1. Let me see, show interface status. Port channel 1 is connected. Show interface status. Port channel 1 is actually active. So MAC address table. Show MAC address table. Port channel 1. Ethernet 1 is port channel 1. Okay, now let's test the redundancy of MLAG connectivity. So I'm going to test the redundancy of MLAG connectivity now. So what I'm going to do now is I'm going to shut down this interface. I'm going to then shut down this interface. I'm going to continuously ping from host to the WAN. Okay, so from host to the WAN, I'm going to ping. I'm going to then shut down some interfaces. Then we'll be seeing the continuous ping. Okay, let's go back here to spines. So I'm gonna ping first. Let me ping this guy. Ping 192.168.99.2. Okay. I'm not able to reach 99.2. So 99.2 is VLAN 99. Show interface status. Okay, port channel 12 is connected. Okay, show IP interface brief. 99.2, it's up. The trunk is full. Show VLAN. Okay, VLAN 99 is already there. Let me go here. Show VLAN 99 is already here. Channel 100. Show VLAN and is already here. Let me suggest what I'm going to do is interface put channel 12. I'm going to say shut. Say no shut. Status. So let me also see the ARP table. Okay, 99.1. Let me see the show IP. So IP 8.8.8, 99 dot. Okay. Okay. Everything is fine. Let me try again. Yes. So now I'm able to reach 99.2. Let me also ping 8.8.8. Yes, I'm able to reach both 99 as well as 8.8.8, which are in the WAN switch. OIP interface brief. So 99.2 and 8.8.8. So let me show here. Show IP route. You can see, so I have for 8.8.8, I'm saying that go to 20.254. And for everything else, I'm saying go to 10.254. So default IP towards 10.254, and for 8.8.8, it will go to 20.254. So I'm going to test both. So what I'm going to do is now, what I'm going to do is I'm going to continuously ping 99.2, which will go through this 10.254. And I'm going to say repeat. I'm going to say 100. And say interval. I'm going to say every 1 second I'm sending one packet. So what I'm going to do is now the pings are continuously going. So what I'm going to do is now I'm going to shut down this interface, which is connected to spine 1. Okay. Okay. Okay, come here. Let me go to the leaf. I'm going to shut down here. So I'm going to shut down this one, Ethernet 2, which is connected to spine 1. Interface Ethernet 2. I'm going to say shut. So I have shut down interface Ethernet 2, and the pings are still going through. We're not seeing any downtime here. What I'm going to do next is I'm going to shut down the next interface, which is this interface. I have already shut down this one. Now I'm going to shut down this one, which is connected to spine 2. On the WAN, I'm going to shut down the interface which is connected to spine 2. Okay, now show LLDB neighbors. So interface Ethernet 2, I'm going to shut down. Interface Ethernet 2. Just a minute. The things are going to be end. I'm not shutting down yet. So, okay, I'm going to reinitiate the same. Okay, now the pings are going through. Now I'm going to shut down Ethernet 2, shutting down. So now I have shut down Ethernet 2, show interface status. So Ethernet 2 is disabled, and spine and leaf also show interface status. Here Ethernet 2 is disabled. But now how the traffic is going through is, now the traffic is actually going like this. So this interface is down, this interface is down, this interface is down. Now the traffic is going like this. It is going like this right now. Okay, this is going, the traffic is now right now going like that. So now what I'm going to do next is, now I'm going to ping 8.8.8. Now this time I'm going to shut down this interface and this interface. So the traffic will have to go like this. Okay, so that we will be doing that now. Okay, let me just stop this. So this time I'm going to say longer. I'm going to continuously send ping. I'm going to send 1,000 pings. So I'm sending 1,000 pings now. So let me just no shut it. Let me shut no shut, and on the WAN also I'm gonna say no shut. Okay. So now spine. So sorry, I was supposed to ping 8.8.8. 8.8.8. I'm gonna say repeat. I'm gonna say 500 times. I say interval every 1 second. I'm sending 500 pings every 1 second for 8.8.8. 8.8.8, and now it's going through 20.254. So LDB neighbor. So now I'm going to shut down Ethernet 3, which is connected to spine 2. And here, so LLDB neighbor, I'm going to shut down Ethernet 1, which is connected to spine 1. Okay. Okay. Ethernet 1, I'm going to shut down there, and Ethernet. Okay. Ethernet 3 here. Interface Ethernet 3. I'm going to say shut. Pings are still going through. There's not a single packet drop. And I go, so interface Ethernet 1 actually. Interface Ethernet 1 is actually, sorry, interface Ethernet 1. I'm going to say shut. The pings are continuously going through. Okay. So shut down this one. Sorry, shut down this one. Show, show. So just a minute. I can just show you the show LLDB neighbors. Now I can't see this spine one. It's only I can only see spine two here, and here. So I can see spine one here, and I can see spine two here. Spine two and spine one. So right now, Leaf is sending the traffic to spine one, and WAN is actually receiving the traffic from spine two. So WAN is receiving the traffic from spine two, and Leaf is actually sending the traffic to spine one. So what I'm going to do now is I'm going to just interface Ethernet 2. Sorry, I'm going to just say no shared interface Ethernet 2. Okay, sorry, interface Ethernet 2. I'm going to say interface Ethernet 2. I'm going to say shut. Okay, interface Ethernet 2 is shut. Here, I'm going to say no shut. The pings are still going through. There's no packet drop. The pings are going through interface Ethernet 2. I say no shut there, and I'm going to say shut. So I have actually shut down multiple interfaces. Show LLDP neighbors. So now it is connected to spine 1. Before it was connected to spine 2. Now it is connected to spine 1. And let's see this guy. Show LLDB neighbor. So now look at this. Now this guy is connected to spine 2. Earlier this guy was connected to spine 1. Yeah, yes, spine 1. Spine 2 was not there. These are management interfaces. So spine 1. Now it is connected to spine 2. So even with multiple link failures, you look at the redundancy of MLAG. So actually the VARP and Anycast gateway, they are leveraging the underlying MLAG, which and MLAG provides the redundancy for the links. So link level as well as switch level redundancy is actually achieved through MLAG, and the gateway redundancy, the IP level and the MAC level redundancy is actually achieved through VARP and Anycast gateway. Okay, so this is what happening. This is what happening now. What I'm gonna do is I'm gonna go to the spine. Gonna see to show MAC address table. Show MAC address table. Let me see the MAC address table. The MAC address table should be identical. Okay, 34455. Okay, 100 4455. If you look here, the MAC address table is actually identical. So port channel 1, I'm getting this 1EF6, and here 1EF6 should be here. Port channel 1. So MAC address table VLAN 10. Look at the MAC address table for VLAN 10. Seeing port channel 100, 713AD and 7171199F. 199F is the okay. Port channel 100 is actually the peer link. Okay. Hmm. So ARP. So ARP is actually 99.2, 99.2, okay, 100.2. Okay, the ARP table is actually synchronized. If you look at the ARP table, it's the same ARP table, almost identical. Except that VLAN 100, VLAN 100, VLAN port channel 100, this is VLAN 4094. We accept VLAN 4094, everything else is identical. So that is the benefit of using MLAG with VARP and Anycast gateway. So if it is just an MLAG, we'll be seeing this identical MAC table. So we are not seeing the identical MAC address table here. The MAC address table is not identical, but the ARP table is identical because we have configured the VARP and Anycast gateway. So both switches are they have the same ARP table. So this is how they are achieving the redundancy, having the same virtual IP and the same ARP table. Okay, let me go to the pings are still going through. There is no. Let me stop this. Okay, okay. There's no packet drop. So I hope you have understood MLAG and how VARP and Anycast gateway work in this case. So basically, what happens? A final explanation on what happens. So both spines will have the same IP, same virtual IP, and same virtual MAC address. Basically, they are in MLAG, so they have the same MAC address and same IP address, virtual IP address, and the host will will have the same single gateway IP, single MAC address. So both spine 1 and spine 2 will be responding for the ARP request. If any ARP request is sent by host, any one of the spines will receive the ARP request, and the whichever spine receives the ARP request will respond. It's not that one spine will respond, the other spine will be standby. It's not like that. Both spines will be active, both will be responding for ARP request, and both will be forwarding traffic by using the MLAG underlay. So thank you for watching the video. And in the next video, I'm going to be configuring a complete L2LS. So L2LS stands for layer 2 leaf spine. So I'm going to be configuring a layer 2 leaf spine fabric, a complete fabric. It will have like at least 2 spines, 4 leaf switches, and 2 hosts at least. So I'm going to be configuring that in my next video. So, and thanks for watching the video.